This is a video for the bookwork from section 3.1. I have another video from the picture page worksheet, but these were the problems that I took out of the book. Again, this is from your textbook, so use your book, use your book, use your book. Really quick, domain are the X's, range are the Y's. Domain are the X's, range are the Y's. Let's see if I can change the pen color. All right, we'll try to use green. Okay, so these would be your X's. This is an X, this is an X, this is an X, this is an X. There's only one X for this particular problem, so it's just -2. And then you just list out your Y's for the range. You would have 5, 3, 0, and -9. Now, the book would put those in order, but I don't really care. Let's look at one of these. I have more information on domain, range, increasing and decreasing on the picture page video. So if you need more help, please refer to that video. But I am going to look at one of these with you. All right, let's look at this one. Domain and range. Domain goes from left to right. These are your X values, and you're going to look at the picture from left to right. So if we look at this thing to the left, it's going over and over and over to the left for all infinity. And we know that the left is negative infinity specifically. And then if you look at it to the right, it's going to go to the right forever. And the right is positive infinity. Oh, somebody's coming to my house. Hold on. Okay, you might see some movement behind me at that door, but I'm going to have to keep rolling. My family just got home. All right, where was I? Domain and range. So we're going to the left and to the right. Some people get confused there because they say, well, you're going down. No, 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 no. Domain is left to right, left to right. So from the left, you're going to negative infinity, and to the right, you're going to positive infinity. Okay, let's look at the range. Range is down, up, down, up. So the lowest this thing is ever going to go in both directions is negative infinity. And the highest it ever reaches is 0. So our range is negative infinity up to 0, and then you put a bracket at 0 because it actually touches there. Okay, now let me see if I can change colors. All right, let's go to purple. So we have increasing and decreasing. So for increasing and decreasing, this is where you get on the ride. This is like a little roller coaster. Again, ignore the distraction behind me. I apologize. You always sit down on the ride on the left-hand side. Sit on the ride on the left-hand side. Sit on the ride on the left-hand side. All right, and so if we were to ride this roller coaster from here until this point right here, okay? Here's what you call the turning point. I honestly cannot see that. I think it's 3. You look at the X coordinate, though, not the Y. So from the left, which is negative infinity, all the way to 3, your body would be increasing. In other words, the roller coaster would be rising from negative infinity until it hit that moment. So it's going to be increasing from negative infinity to positive 3, and you always put a parenthesis with increasing and decreasing. You never put a bracket with increasing and decreasing. All right, from 3 down, you're going to be decreasing. So this half of the graph is decreasing. All right, so you start decreasing at 3, and you decrease to the right. Okay, you're going to the right here, not to the left, and also not down. So from 3 to the right, which is positive infinity. And for increasing and decreasing, you always put a parenthesis. You always put a parenthesis whether you are increasing or decreasing. Okay? I went over the rest of this on the other video, so you can look at that other video. But let me go over this restrictions page. This is something that people struggle with. We've got it on our notes. If you have filled out your Chapter 3 notes, you already have some information here. But let me just go over a few. First of all, I've written down the implied domain or restrictions. There are 2 restrictions on the numbers in life. Number 1, you can't ever have a negative under the radical. We know that because you can't take the square root of a negative. This would be a fake number. This would be an imaginary number. This would be too I. And so that's a restriction. You cannot graph 2i. That's why these restrictions are in place, because you cannot graph these particular things. And then the other restriction is that you cannot have a 0 in the denominator, okay? You cannot, remember I told you this, if you have a 0 in the top versus zeros in the bottom. Now let me repeat this in case you were absent. If you have a 0 in the top, that is okay. Your answer is just 0. But if you have a 0 in the bottom, that is what we call a no. You cannot have a 0 in the denominator. And so your answer would be undefined. All right, let's go through these really quick. So number 77, again, this is in the book. In the book, this is section 3.1 in the textbook. So look at your book for all of these examples. But the first thing we see is that you can't have a negative under the radical. So we say the stuff under the radical has to be greater than 0. Now, you have to ask yourself whether or not it is okay for this to equal 0. And here it is okay. So you would add an equal to 0 since it's in the top. If the radical is in the top, you set it greater than or equal to 0. So you just would solve that x minus 1 is greater than or equal to 0. You get x is greater than or equal to 1. If you were to graph this, it's going to be a closed circle and shaded to the right. And then as an interval, let's see, this is going to be bracket at 1. Please forgive the people coming in and out of my home. I really apologize. I try to make these videos while no one's at home. And when I started this one, I was home alone. And now, 6 minutes into it, my whole family's here. I apologize. Okay. So there we go. That's how you would write it. This is what probably the book and the Hawk software was going to require. Let's look at this one. This one does not have a radical. So rule number 1 does not apply to this problem, but it does have a denominator. So this stuff that is in the denominator cannot equal 0 because 0 in the bottom is a no. So what you're going to do, you're going to set x squared minus x minus 6 not equal to 0. This can be factored. It'll be x minus 3, x plus 2, not equal to 0. And when you solve each of those individually, you get that x cannot equal 3, and here you get x cannot equal negative 2. Okay, I just want to go over one more here. Let's look at number 87. And this is, I've changed this on the worksheet, so ignore this. If you're looking at a new copy of my worksheet, this problem is no longer there. If you have an old copy, you might see that one, but just kind of ignore that one. That's not a very good problem. But let's look at number 87. You have 2 rules, no negative under the radical and no 0 in the denominator. Well, the only part of this that's under the radical is the x plus 6. You don't care about that plus 1. That has no bearing on the restrictions. It's just that the stuff under the radical has to be greater than 0 because it has to be positive. Now, if this were in the denominator, I would not add an equal to because you cannot have a 0 in the denominator. But since it's in the top, it's okay for me to add that equal to 0. So the answer here would be x is greater than or equal to negative 6. If you were to graph that, you would have a closed circle at negative 6 shaded to the right. And this would be bracket at negative 6, comma, infinity. Now, let me show you an example. I'm going to change my color here because I want to show you one that's a little bit different than anything. I substituted in this example, but let me just make one up. Let's say we have f of x equals 2x over the square root of x plus 5. Let's just make this up. Okay, now this is different than number 77, and this is also different than number 87. If you notice these two had the radical in the top. So the radical was in the top, and all we had to do was set it greater than or equal to 0. But this example, which I just made up for this video, is different because we have a radical in the bottom. So what that means is that both of our restrictions are going to apply. We cannot have a negative under the radical. So we know that this stuff that's under the radical, x plus 5, this has to be greater than 0. But if you look at your other rule, you cannot have a 0 in the denominator. Because of that, I cannot add an equal to 0. See up here, look at these again, 77 and 87, your x and your radical, these were in the numerator. They were in the top. And it's okay to equal 0 if it's in the top. But this x plus 5 is in the denominator, and that cannot be 0. So that is a major difference between those two types of examples. This one would be x is greater than or equal to 5. That's going to be an open circle and shaded to the right. And so your interval would be, that's supposed to be a negative, parentheses -5, comma, infinity. So these are the notes for 3.1 continue, specifically stating the implied domain or restricting the domain.